Welcome to 9.3, and in 9.3 we're going to plot nonlinear functions, functions that are not a straight line. So let's evaluate some functions. All of these are nonlinear functions because you'll notice the exponents are not 1. So let's practice evaluating a nonlinear. Well, these are expressions, but they'll be functions today. So 3 squared equals 9. 5 times 3 squared. Remember, exponents before multiplying, order of operations. So 3 squared is 9, 5 times 9, 45. Negative 5 times 3 squared, still exponents first, 9. Negative 5 times 9, negative 45. 3 cubed, 3 times 3 times 3, 27. Negative 5 times 3 cubed, you have to do 27 first. And so 27 times 5 is 35, and we get negative 135. Oof. Negative 135. Okay, so that was evaluating expressions. But we're going to be graphing things that look like that are a U shape. Now let's look at this shape. Because when you graph it, you might be tempted to make a V shape, and there is a function that is a V shape, but the one we're doing today is not it. It's a U shape. This is curved, all right, and it's curved everywhere. Even there, those straight parts there, they're actually curved, and it's curved forever. All right, so label each as a function or non-function, linear or nonlinear. All right, so this is what we've been doing. This is a linear function. Okay, you put one x input in there, you'll get one y out. That's what we graphed in the last unit. This is a non-linear function because the exponent of x is 2. That makes it non-linear. It's still a function because we're going to put an x in there, and 1 squared is 1. We'll get 1y. This is also a non-linear function because it's non-linear because the exponent there isn't 1, it's 3. And it's a function though. You put an x in there, you'll get 1y. 1x will make 1y. All right, x equals y squared. What the heck is? You put x in here and you say x is 6, or let's do a better one, 9 equals y squared. Y could be more than one thing. This is not a function, right? It starts with x, but that's only partly the reason it's not a function. It's not a function, and so we're not going to deal with that, right? We're going to be doing nonlinear functions that all start with y, and today they're all going to have exponents that are not 1. All right. When it's x squared, you get a U shape, and the name of that U shape is parabola. So let's describe the shape of each. So the exponent there is 1. So what's the shape? It's a line, because that's a linear function. Exponent is 2. That means when you graph it, it's a parabola. That's how you pronounce that. This one on the left is a line. This one on the right is a parabola. Okay, because the exponent of x is 2. Okay, so we're going to graph our first parabola. This is the simplest one you can do. Y equals x squared. We're going to make a t-table. So negative 3, and you need those parentheses. Negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. Now notice there is symmetry here. Parabolas are symmetrical, which means they're the same on both sides. That's what the symmetry is all about. We got the same numbers there. So let's plot this. The first point is negative 3, 9. And you're going to make a little sketch. Negative 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, like that. Okay. Then negative 2, 4. Then negative 1, 1. Then 0, 0. And then we go back up because this is, you know, when you see this, you're going to get a U shape. So then 1, 1, 2, 4, and 3, 9. And so now I'm going to graph that. Now, I know it's curved everywhere because Mr. Ben has told us that. All right. And so try not to make it look like a V. Try to make it look like a U. No pointy parts. Try to graph it better than me, though. There it is. And arrows on the end, just like linear functions, these go on forever. And that is our first parabola, y equals x squared. Okay. Now, if I gave you a bunch like 1/2 here, and we did 1/2 squared, would be 1/4, and we plotted things like that and a bunch of fractions, you would see how curved this is at the bottom. It is not a V. All right, so let's try this one. It's also going to be a U shape, a parabola, y equals 1/2 x squared. So we have to do half of -4 squared. -4 squared is 16. Half of 16, 8. Half of -3 squared. Now, -3 squared is 9. Half of 9 is 9 halves, also known as 4 1/2. Half of -2 squared. -2 squared is 4. Half of 4 is 2. 1/2 of -1 squared. -1 squared, -1 times -1. Half times 1 is 1/2. 1/2 of 0 squared is 0. 1/2 of 1 now. 1/2, you've done the hard part because you're going to be symmetrical now. It's going to be just like, we're going to get the same numbers again. 2 squared is 4, half of 4, 2, right? Half of 3 squared. 3 squared is 9, half of that. 9 halves, or 4 1/2. Half of 4 squared. 16, half of 16 is 8. Okay, so now we're going to plot these points. So we have the point -4, 8. You're making a sketch. Don't go crazy. -3, 4 1/2. 4 1/2 is halfway between 4 and 5. So it's going to be right there. -2, 2. -1, 1/2. 1/2 is halfway between 0 and 1. 0, 0. Now remember, we're going to go back up and it's going to be symmetrical, right? We get another 1/2, right? And then at 2, we're going to get another 2. And then at 3, we're going to get another 4 1/2. And then 4, we're going to get another 8. Okay, and then we're going to draw our U shape. This one's wider than the last one. And so this one's nicer. You can see that it's more curved and looks more clearly curved than the last one. And that's our parabola. All right, so is this point on the parabola? Same thing as yesterday. You put this y, right? This is x and y. You put this 75 where y is. You put the 5 where x is. 5 squared is 25. 3 times 25 is 75. Yes, that point is on the U shape. Okay, and that means we know that 576 is not on there. 5 is, if you put 5 in there, the only output you can get is 75, nothing else. All right. Right, the area of a square. All right, plot the relationship between the length of the side and the area of a square. This is the standard that you can do this. All right, so right, instead of x and y, you have s and a, but it's the same thing. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So it has 0, 0, 1, 1, 2, oh, no, look at Mr. Ben. Mr. Ben has to be careful. Look at the scale. I changed the scale here. The scale on the x-axis is the same, but I changed the scale. So 0, 0. So this is 1, but 1, this is 2. So 1, 1 is halfway up to 2. 2, 4, 3. So this is 10 right there. 9's halfway between 8 and 10. 4, 16. I did that so you could see this. And then 5 goes with 25. Well, that's 18 and that's 20, so it's way up here. Okay, but notice, all right, so I'm going to draw the U shape. Well, what happened to the other side? Well, what happened to the other side is, can the area of a square, right? So this is a square. We had, let's just go over this, right? We had a 0, 0 square, but then we had a square that was 1 by 1. and then we had a square that was 2 by 2. I should make it look more like a square than a rectangle. Then we had a square bigger, when we're getting the squares bigger and bigger, and we're finding the area, right? And then 4 by 4, and then 5 by 5. And the area gets bigger and bigger, but we don't have any negatives, so we don't have this side of the square, of the parabola. But this is half of a parabola. It is. And we know that because there's a square there. It doesn't have to be x squared. In this case, it's the side squared. All right, so x cubed does not make a parabola. The shape doesn't have a name. I've made up a name, bad chair. Because if you sit in this chair, you're going to fall out. Let's see that. So y equals x cubed. Now, negative 2 cubed, right, is negative 2 times negative 2 times negative 2. There's 3 negatives in there, so it's negative 8. And you need these parentheses around the negative 1. Negative 1 cubed is negative 1 times negative 1 times negative 1, negative 1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. So I'm just going to graph this very briefly. Negative 2, 8. Negative 1, negative 1. I have normal scale again here. 0, 0. 1, 1. And 2, 8. Okay. And what this does, it goes like that. All right. And they make the shape where if you tried to sit there, you'd fall off. It's a bad chair. And that happens every time there's x cubed. All right, so let's practice. All right. So is that a function? Yes, it's a function, and it's a non-linear. It is a function, but it is a non-linear function. And notice that the u is upside down, and that's caused by that negative in front. The negative coefficient causes upside down u. Okay. So we're going to check if this is in. We're going to put the negative 50 there. Equals negative 5 times 2 cubed. 2 cubed is 8. Negative 5 times 8 is negative 40. No, this is not on the line. The one that is on the line is negative 40, right? This side, all right? 2 negative 40 is on this shape. This is a bad chair. This one actually, because of the negative sign, I think goes that way, faces the other way. But the key is that this point is not on that curved line. Label each as a function or non-function, linear or non-linear. This is a linear function, right, with an exponent of 1. This is a non-linear function because it has an exponent of q, and even with that plus 1, as long as you have that cubed, you're going to get the bad chair. That's what determines it. All right, so now, volume of a cube, right? A cube is the 3 sides cubed, side times side times side. That's an S, not a V. So, right, so if the side is 0, the volume is 0. The side is 1 times 1 times 1, 1. 2 cubed, I should write this out. 2 cubed is 8. 3 cubed is 27. 3 times 3 is 9 times 3 is 20. 4 cubed, 16 times 4 is 64. 5 cubed is 125. All right, so 0, 0. I messed with the scale here, by the way. You can see that. 1 cubed is 1. Now, this is 8, so 1 would be right there. And then 2 cubed is 8. 3 cubed, now this, we're going up by 8, so I need 3 cubed is 27. So there's 24, so 27 is about there. And then 4 cubed is 64, and 5 cubed is way off the graph up there. And what this is, again, this is just the positive side, right? The rest of this goes there, but the side of a cube can't be a negative number, so we leave that whole part out. All right, you're going to be graphing some nonlinear functions in the homework. Good luck.